So once again, this internal resistor is going to use up some energy. How much voltage is it going to use up? It's going to be V equals IR, Ohm's law. So that tells me I'm going to use up 0.04 volts, which means how many volts must this use up?
The rest of
It must use the other 1.5 volts. Does that make sense? And then, so what power equation do I have that has volts and current? The first one, the easiest one. P is what? Right? P is IV. And that's 0.16 times 1.5, which is going to give me 0.24 watts. And then to get the energy used in 60 seconds per minute, because this is the energy per second, right? A watt is a joule per second. So all I have to do is multiply this by 60 seconds, and then that'll give me the joules per minute. So then 60 times this would be 1.44, so like 12.44 joules. But that's all mental math, so I could be wrong.
So like a double A battery.
No, that's not right. It's not 12.4, is it?
Oh, this is the
Yeah,
battery.
okay.
This has no battery.
Yeah.
Sorry, no battery.
Your EMF has dropped below the...
So when
Yeah.
you multiply by only the bigger
The 1958 calculator.
Multiply, I'm sorry, would you...
So in your
I'm pretty sure
part
we do
A,
about this
the
big.
Uh-huh.
IV, why do you not
Each of
multiply
them.
by 1.54?
Oh, well, okay, 1.54 is the EMF, right? And then we know that that EMF gets used up throughout the whole circuit. So if you pretend that this little internal resistance, don't worry about being inside, just put it outside, because it's all one circuit, which means it has to have this current. So then what we're trying to find out is, I need to know about this resistor out here. I need to know its resistance, or I need to know its voltage, because I already know the current. Does that make sense? So if I can find the resistance that it has, or if I can find the voltage that it uses up, then I'm good. So I know the total voltage right here, right, the total possible, and then I can calculate how much I lose of that because of the internal resistor. That means whatever I have left has to be used up out here. That's why I subtracted the 0.04 from the 1.54.
It's 14.4.
Oh, see, that's what happens when you use mental math, kids.
Where did 0.15 come from?
0.15. Where's
Or
0.15?
is it 1.5? Like,
Yeah, it's 1.5.
oh,
Because that's 1.5 for minus 0.04.
wrong
Gives you
one.
1.5. Okay, any questions?
Or you just use Ohm's law, right?
Yeah, so basically, I'm just using the loop rule, Kirchhoff's loop rule that says the total voltage has to be 0, and I'm using Ohm's law, and then the power statement. That's it. So the loop rule, Ohm's law, and power. Those are the three things that I use to solve this.
So like a double A battery has 14.4 joules of power.
Probably not, because it probably doesn't run out in 60 whatever in 1 minute.
But then
That's why in a
0.28
battery,
watts then.
things are like this. It's amp hours, because an amp is a coulomb per second, right? And so then that's multiplied by 3,600 seconds, and then that gives you the amount of energy in a battery on average.
But the point